Here we are, our last notes, the last notes of vectors, the last notes of the second semester, the last notes of the year. Last notes. Vectors. Number 3, applications. Let's just do it. So the first thing is work. You've probably heard of this in your science class. Work is force times distance. Force and distance are vectors, so we're going to multiply. So we're going to write the force vector in component form. Force is given by 7i plus 6j, so wouldn't that be just 7 comma 6? It moves an object from 2, 1 to 5, 6. So I always got to make a little thing. From 2, 1 to 5, 6, 2, 3, 4, 5. So it moves over 3. And then if it goes up to 6, isn't that like up 5 from 1? Yep, so 3, 5. So we're going to do force times distance, which is 21 plus 30, which is 51. And I always forget the units. I think it's joules. We've had this conversation before. I'm honestly okay if you just write 51. This is going to be some 30, 60, 90 action. Meg pulls a wagon, force of 20 pounds on the handle, and the handle makes a 60, so it's a 30, 60, 90. This is in this 10 and 10 root 3, so it's in the force vector 10, 10 root 3. Find the work done to move the wagon 100 feet. It doesn't say which direction, but I'm going to assume it's just to the right. So the distance would be going 100 feet to the right and nothing up. So the work would be 10 times 100 or 1,000 plus 10 root 3 times 0, which is 0. So it's 1,000 joules. Force, distance, multiply them together. Then we're going to do some airplane questions where we're talking about velocity and speed, and it gets a little confusing. I just remember velocity is a vector and the magnitude is that number of the hypotenuse, right? So airplane is flying due north at 280. So this is a vector that's talking about the original plane. If it's going north at 280 miles per hour, speed is the magnitude. So this would be 0 to 80. Or it says in terms of I and j. So 0i plus 280j. The wind, crosswind, 38 miles per hour, N60E. So this is 38. And remember, never eat soggy waffles. Just don't do it. Never eat soggy waffles. This you have to understand. So N60E means as if you were going north, but you turned 60 degrees towards the east, or 60 degrees east of north. So what that gives us here is a 30, 60, 90 triangle. There's the 30, there's the 38, this is a 30, 60, 90, because that angle was 60 because of that. So then this is going to be what? 17, 17 root 3. So this is 17 root 3 comma 17, or 17 root 3i plus 17j. Add the vectors to find the true velocity. So what you're really happening is you have the plane here, and then you're adding on the wind, and then you're getting what's actually happening to the plane. So if we add those two vectors together, it says component form and I and j. So component form would just be 17 root 3 plus 0, right? And then 280 plus 17, isn't that just 297? So 17 root 3i plus 297j. So now we're going to find that actual magnitude of this vector. So I'm going to write it here. That's like the true speed, the way the plane is actually going. And it has a horizontal component of 17 root 3, which I'm getting from here. Vertical component of 297, which I'm getting from there. How do I find the hypotenuse? Oh yeah, 17 root 3 squared plus 297 squared equals c squared. Going to my calculator here. So 17 root 3 squared. Oops. It's actually a little bit annoying to do. Not gonna lie. I'm going to actually, here we go. So 17 root 3 squared plus 297 squared. I got 89076. So if I square root that, I get The magnitude is 298.46, and it's miles per hour. So if you kind of think about it, like it started out going 280, and then this wind is kind of pushing it, so it's going a little faster. To find the actual direction of the plane, that's that angle. So that's saying second tan of 297 over 17 root 3. So second tan of 297 divided by 17 root 3, and that turns out to be 88 degrees. So it's 88.11 degrees. But here's the thing. We have to do this in terms of north, south, east, west. So if I, go back here to never eating soggy waffles, it's as if I'm going east, but went 88.11 degrees towards the north. Now, another way to think about that is you could subtract that number from 90. Some people like to think of it as like going north and turning 1.89 degrees towards the east. Towards the east. That's also true. So like either of those are fine. I know the story problems are tough, so I have one other one. So we'll do the one with the boat. The boat is N30 west at 24 miles per hour. So what do we never eat? Never eat some soggy waffles. N30 west. So it's like you're starting out north, but you're going 30 degrees towards the west, and the magnitude is 24. That's the length. So if I write that in terms of component form, this is going to be a 60-degree angle, 30, 60, 90, 12, 12 root 3. No. So the component form is negative 12, 12 root 3. The river is N30 east. So what are we never going to eat? Soggy waffles. N30 east. So it's like you're going north, but you turn 30 degrees towards the east, and the length of that vector is 8. If we're going to do that in component form, this is my 30, 60, 90, 4 root 3. So it's right 4 up 4 root 3. The resultant vector is going to add those two vectors together. So if I did it visually, it would be like taking the original boat, the original boat, adding on the river, and then resulting in like what's actually going to be like the true velocity, this green vector. So I'm going to add negative 12 plus 4 is negative 8. 12 root 3 plus 4 root 3 is 16 root 3. And I'm going to redraw a vector that's negative 8, 16 root 3. So that means it went left 8 and up 16 root 3. So this is like the true velocity. If I want to find that speed, a squared plus b squared equals c squared. Or 64 plus, let's see, that's going to be 768. So if I add that to 64, I get 832, and I'm just going to do this as a decimal. Square root of 832 is 28.84 miles per hour. That's the magnitude of that vector. If I want to find the direction, that's this angle right here. Well, that's the reference angle I'll find. So I'm going to do second tan of 16 root 3 over 8. I can keep that positive. And I can change that to second tan of 2 root 3 if I want, just reducing that. Second tan of 2 root 3 is 73.89 degrees. Actually, when I round it, it's really 73.90. So now I got to think again. I never eat my what? Soggy waffles. So it's as if I'm going west, but I turned 73.90 degrees towards the north. If you wanted to, you could subtract that from 90 and also think of it as if I was going north, but turned 16.10 degrees towards the west. Those are equivalent. I don't think you need to do that. I'm like more a fan of just using the angle that you get. I know the north, south, east, west stuff is a little bit tricky, so we can go over that more, but that is it. Vectors number 3. Done. Vectors number 3.